Alright, so today we're going to be talking about how a motor works and how to make an H-bridge motor driver. So to start the motor, I'm going to use this symbol, a circle with an M in it, and there's going to be two leads. I'm going to call one a side 1 and the other one is side 2. And now how a motor works is if you put a positive voltage on one pin and a negative voltage on the other, and voltages, as you know, are respect to each other, so this would be, say, plus 5 volts, and this would be tied to ground. The motor will spin one way or another. For the sake of argument, let's say that the current flows like this. So this would be a clockwise motor spinning. Now you can also do with the exact same pins, so 1 and 2, just as before. Now we're going to switch the polarity, so we're going to make the number 1 pin go to ground instead, and the number 2 pin go to plus 5 volts, and this current flow will be the exact opposite way, leading to a counterclockwise spin. Now there is one more case. Instead of having both pins open like they are, you can have both leads touch each other. Or actually, there's two more, I should say. You can have both leads touch each other, and because a motor, when you're not passing a current through it to make it spin and you're spinning it manually, like mechanically, it'll generate a current as a generator. So when you tie the leads together, this will cause it to resist turning, and so you get a brake condition like in your car brake, so it will not turn if it's a good motor. And then the other condition when you're not applying current and you're spinning it mechanically is to have a open, or better yet, you can do for the future, this will become apparent why I'm doing this in a little bit, you can have a diode, two diodes, and you can connect the leads together and drop it to ground. And now this will allow it to coast because the current cannot go against the diodes, so it must drop straight down. And you can spin it freely after this point. So, the H-bridge motor driver. For this H-bridge, I'm going to make an assumption that my transistors, which will be denoted with this little symbol, and then there's two connections, and a third one is the gate. This I'm going to say is only a switch, so you can think of it like this. Alright, so now this H-bridge motor driver. So we'll start with our motor in the center, and it will of course have its two leads coming out. And then we have a couple ground planes. We have plus 5 volts here. Well, that's just what I'm saying. It can be any voltage you want as long as the motor can handle it. And my ground plane. Let me get rid of that line. Alright, so then for my connections, I'm going to make an H shape out of transistors, so it'll look something like this. This is bad looking. Alright, let me try redrawing this. And then this other side will have 1, 2. And of course, they will have their leads coming out. And on the bottom, we have the exact same thing. And like I said earlier, to make it in the coast position, which I always like to have, I'm going to put my little diodes on. That's a bad look. And here's my transistor on this side. Alright, this is a bad drawing. Maybe later I will draw a better picture, but as for now, this will do. Okay, so now the important parts are what states can these take. We'll use 1, 2, 3, 4. Alright, so what states can these take? Well, we can have we can have a few inputs and outputs. So let's call this inputs. And let me get a little more room. Outputs. Alright, so my inputs, I can turn 1 and 4 on. I can turn 1 and 2 on. I can turn 2 and 3 on. I can turn 3 and 4 on. And these will all be legal. So for sake of arguments, we'll say 1 to 4 is clockwise. Okay, 1 to 2 would be a break condition. 2 to 3 would be counterclockwise. And 3 and 4 would be a coast. Ooh boy, I cannot write today. Alright, so then you might be asking yourself, well, what happens if you do 1 and, there it is, if you do 1 and 3, or 2 and 4 at the same time? Well, this is what's known as your fuse test. And why is it called a fuse test? Because you're basically testing to see if your fuse will blow before your transistors. So this is a no-no state. And you'll actually end up having a short circuit. So let's examine this. Alright, so for 1 and 2 being on, the current will flow from 5 volts, or I mean 1 and 4, sorry, will flow through transistor 1, go over the motor, come down through transistor 4, past the diodes, and down to the ground plane. For 1 and 2, it'll start either at 1 or 2, doesn't really matter. We'll do it on 2. Come down, go through the motor, and go back up. And you'll see through this loop that 1 and 2, these leads right here, are connected to each other. Therefore, as mentioned previously, you have that negating effect in the motor, and it will not drive. Alright, so 2 to 3, let's start in here. So it'll come through the 5 volts. It'll go through the motor. It'll come over to the 3, come down, go past the diodes, and down to the ground plane. Now the coasting idea, we're going to start anywhere really. We're going to go through, go past the diodes, or the first diode. And now you see that we can't go against this other diode because there's that line. And if you learn the electronics, you'll find out why. And we'll come back down to the ground plane, so that allows it to spin freely. And then the fuse test, which you're never ever going to want to do, is you're going to come through either 1 or 2 and just drop straight down to the ground plane. And you never want to reach this because you'll burn out 1 or 3 or 2 or 4 or all 4 maybe. So never really enter this state. Now, how do you guarantee that you never enter this state? Well, there's a couple simple solutions. Well, there's one really simple solution that doesn't really do you much good, so I'll go over that one. And if you need some more exotic solutions, you can build those yourself, or you can buy one. It's probably easier just to buy one because there's a lot of control circuitry behind it. Or you can just do the whole emulation of it in software. So if we have our H bridge, which I will draw like this, and I'm not really going to draw any other connections because you know how that's set up. You can look up above. Now you will see something interesting. If I put 1 on, let me come back up. If I put 1 on, I never want to turn 3 on. So I can make the pin 1 correspond to a state of 0. So this is the 0 state. And number 3 will correspond to the 1 state. Now the same thing happens over here. So I'll make 2 the 0 state and 4 the 1 state. So then how do we make our thing guaranteed to never trigger a fuse test state? Well, let's put an inverter. on that pin, and then we can draw the line straight down, and we'll do the same thing on this side. Put a little inverter, draw it up, come down, pull the feed line through. So now you see, if I put a 0 here, I'll get a 0 here turning this one off, and I will get a 1 here turning it off. A 0 here inverts to a 1, which turns this one on. On this other side, we'll do this. These are identical. So this side was the 0, this side will be the 1. So if we put a 1 up here, we get a 0 or off, and we get a 1 down here, which is on. And that is the very simple way of doing this. The reason it's not very handy is because you only get one speed, forward or backwards, and you get your brake and coast positions, and that is it.